Hello, today we will talk about debugging. We'll talk about SysML simulation debugging tactics. This topic is quite common. We have this request all the time, how to find the issues with the model. And there are numerous ways to do it. But first of all, first things first, what are the common issues? So first of all, it is incorrect or incomplete SysML model. And there are a few specific places which we see all the time. So to execute action, you require tokens in all action inputs. And this presentation will be organized as a demo. So we'll go through some slides and we'll see in the model. So here you see, for example, activity, right? So if you don't have this merge, after this step, you'll have input here. Looks like cycle is okay, right? But then at this moment, when you come here, you need all the inputs. So this input will not be available. That's why merge is needed. And if we can run it, we'll see. Oh, see, okay, it's failed because this input is not available. So we come here and this input is not available and we fail. So we need to have merge here. Like this. Now, state does not stay active if transition from state has no trigger or guard. That's a very common problem, and you can see here, if you enter the state and there is transition without trigger, you'll see what happens. You know, it's already automatically triggered by that. And more common case, when we have exit final state, which is not even mandatory, but people do it, you know, and it's easy to forget that we need transition trigger or guard here, because when we enter, we automatically go to final, and that's different than transition from initial, because here we don't put triggers, don't put guards. Here we need to put it, otherwise we will just quit automatically. As you can see here, run, you see, done. No signals on send accept event actions. If you create those accept and send signal actions and you just name them in specification, signals are not available, and then it's not clear when we are sending or accepting event. So you need in the recent releases, you just type the name when you create accept or send signal action, and that creates the signal. For example, here you see. Now I got that signal created, you see, and it is associated, you see, signal. But if I would not have that signal, like this, and then would type the name here, looks the same, right? But there is no signal sent, and then you can like look for the error, and this error will be just that issue. And then parametric diagram constraint block parameters are not connected. All the parameters shall be connected. So if you have parametric diagram and you have this parameter, which is C here, and you don't have it connected, or you don't have parameter but they is C, that's already bad. Or if parameter is hidden but it is visible in the model, that's also still need to be connected. Elements in the model are not the same as in the diagram. So in the model, this is the authoritative source of truth, right? But in the diagram, you can have less elements, as we saw, you know, with parametric diagram. So for example, here, I can remove this from the diagram. I can hide that one. If I go to select and containment tree, actually definition, go to the constraint block. Here you see it has two parameters. So it looks like all of them are connected. But when I will execute, it will not perform whatever I want, because this is not shown parameters. So I want to display all parameters. Nothing to create. You see this, even I was confused. Maybe I need to create parameter. Here is just the display parameter. And then here to display value property. And it was already connected. copy paste symbol and diagram element is still the same. So that's another common problem. You know, I see an activity diagram element, copy paste, looks like new element, right? So now I will use this here like this, and then we'll connect this. Looks like everything is okay, right? It should execute, but as a result of that, this simulation you see fails. And why it fails? Because this element has more relations than it shows, because when we copy pasted and then we created another relation, so this got relations, this got relations, all of them got relations, you know, like for example this DB had relation to this, so this one has the same here. Because when we copy paste in diagram, the new element is not created, new symbol of the element is created, and still same element with same relation. So be careful with that. If you want to copy paste in diagram, then paste with new element, paste with new element data. You see, I deleted this and this got deleted because this is that element. I cannot now even delete that element because this will delete this element. So I just remove this from diagram and recreate whatever was missing again. You know, quite easy to forget that at the beginning. No classifier behavior is assigned. So every time you execute the behavior, like every block actually has the major behavior, and that behavior is not only that it's owned, you see like state machine by block, but also it needs to be assigned as a classifier behavior. So in expert properties, here you see classifier behavior. There's a key. You could own multiple behaviors, but only one can be classifier. So for example, those activities can be owned by block, but when I execute that block, only one behavior will be executed. You see like this, when we execute, the state machine gets executed, not those activities. So because it is classifier behavior, so that single behavior will control other behaviors. If it is not assigned in the classifier behavior, then none of the behaviors will be executed. Classifier behavior might be assigned, but execution is not in context. So like for example here, if I will run the state machine, I can run it like this, but then it's not in context of another block. So run it, it updates the properties you see, but there is no properties visible. Now if I want to run in context, run in the context, you see now I have the properties, I run the state machine, it updates those properties, you see. If I will switch to another state, again updates the properties because it was executed in context. So this is one of the most common issues. You run almost always, you know, behaviors in context to run as part of your system, and then the properties of the block will be visible for that behavior. And very common problem that variable name does not match, you know, like for example, here I have temp C, I could mistype it, you know, like this, and then run in context. So here you see this block has temp no underscore C, and if I will switch in state, run in state machine, you see like it looks like it should update to 20, nothing gets updated. If I update here 25, it recalculates in parametric diagram, but this does not affect at all, you know. So this is because we have incorrect property name. Now a lot of problems are with the time properties, and just to understand, you know, the essence of that is that when we run simulation without specifying time properties, it is based on the simulation animation duration. So you pretty much, here you see like if I'm executing like this in context, right? So I see the time is ticking, that time is like PC clock time, and as long as you will want to stay in that you know, state, you can stay. I click on this transition, I switch here. Exit. Same with activities, you know, you execute activity, you see A, then B, Okay, this was another problem with that. I think missing relation, display all paths. You see, this is not needed. Delete. And then animation speed is the only one which controls the duration. One more. Incorrect relation. See? Can speed up. See? So this is animation speed controls duration. But if you want, you can actually specify time parameters, and those time parameters will switch to the precise simulation-based clock, which will take the duration of the constraints. Like here, for example, we have time event 1 second, and only then we will delay some simulation. So we could actually add duration constraints from here. Duration constraints, like 5 seconds, another 1 second, and so. And then that will be exactly time which we will spend. So animation will not affect the time. And those properties which we specify in simulation config. Double click here, and time properties. And here you see start time 0. That switches automatically when you specify start time as 0. That switches automatically to that duration constraint based simulation. You don't need end time if you don't want. Step delay is how long it will take to execute one step. Then step size, like 1, for example, and then time unit. So the step time unit will be seconds. So that means that each second is the one step, and it will be delayed by half second. So it means that physically we'll see that as a half second. So you see now we can control how long we will see one step. If 1, it will be 1 second. If 0, 1, it's 10 times faster, right? 0, 5, twice faster. And that's pretty much it on that, you know. And then when you run the simulation config, you'll see time not ticking until you execute something with the duration constraints, because this has no duration constraint. There's no reason for time to propagate. If I would bet duration constraints here, that would propagate the time. So that's brings us to another second issue. Clock does not start, so you need some time interval to start the clock. For example, here, if I will put, you know, after 1s, that will actually tick, and then I could actually put the duration constraints and then execute this one, and you see after 1 second it re-enters, and that takes half second to execute, because we said that delay is half second. You see time ticks twice faster. So that's number 3 issue, which we already discussed. The duration constraints allows us to avoid that animation-based time interval. We can make it duration constraint based. Then the time of simulation will be based on delay, based on our decision, not based on the animation speed, which animation could be at all avoided. And then one of the other kind of common time issues is chart refresh rate is too high. When it happens is when you go to simulation config and create a timeline chart, you see that refresh fixed time length is 20,000, and if I will create another one, you see refresh rate 1000. So now the time is 1 second, step size 1 second, and here is refresh rate, this is 1000. So if I will use this interval, it will be 1000 seconds. Why it's 1000? Because by default the time 1 unit is 1 millisecond. In milliseconds makes sense to refresh once per second, but in the seconds doesn't make sense, and this will not work. So that's kind of common problem. Now, when you run a simulation, you can actually use debugging capabilities in the animation, with animation and with the buttons here. Now let's go and see how that works. So for example, with the activity diagram, that's very convenient, run. And here I could stop, and you see here are those buttons, run simulation, or resume, or pause, then step into. That step into will step into another activity which is called step over, will step over this level of activity without going into internal activities. Then terminate simulation. Those are the windows, like a session window, console window, and variables window with breakpoints and watch, which we will discuss later. Then here we could click to open active diagram. Here is to show hide clock, then server-side simulation triggering, and then sending triggers like to state machine, like signals and animation speed. So now I could go, when I pause simulation, now I can use those buttons to go see next step, next step, next step. And if I will use this one, this will go inside of this other activity. If I use this one, this will jump to another step. So let's use now this one. You see, I'm now inside. It takes 5 seconds. You see, the time is ticking. Now it takes 1 second. Now again 1 second. This will produce output. You see, output was produced. So now if I will go again, simulate, run, but now use this button, actually, simulate, run, pause, and now use this button. You see, I just jumping from at this top level, so I'm not entering this activity at all. See, it's just that level. Oh, sorry, I clicked that one. But in any case, so like here we would skip that internal behavior, we just execute at that level. And one more button, this one to log session. So I'm executing, let's say with properties, running simulation in the middle of something, and I want to log the session. And now I see those properties, I can continue running simulation, but at the same time investigate what's happening at that moment. Next tool in our debugging toolbox is breakpoints. This is a capability to add breakpoint or multiple breakpoints on any element. When we run simulation, simulation will stop when the breakpoint is reached. How to do it? You can do it from right click. So let's go to the model. And here, for example, in the constraint, I right click, simulation, add breakpoint. And normally parametric diagram is not even animated, but when we run simulation here, because this parametric diagram has this breakpoint added, as you saw from right click, simulation, add breakpoint. Now we have this breakpoint here in the breakpoints dialog, which we can remove from here, add more breakpoints, but also we see animation, and we could actually jump from step to step, you know, and see the properties update and see those, you see values here. So it calculated actually based on the input. Based on this input, it calculated actually result, and we see now animation, parametric diagram, and simulation stopped, and then we can transition through the parametric diagram. And not only through parametric diagram, we can add multiple breakpoints and navigate through the model and track the property change. You see like what are the values. Now the value is different because we entered the state machine. Not here, but here. We entered the state machine, updated the property to 20, this one. And now parametric diagram should recalculate that. Like old value is 69.8. Now let's see how that will change. 68, you see now the value got recalculated. Still not updated here, still not updated here, right? Now it is will be updated soon here. You see now it is updated here. So the breakpoint is the key thing to do the debugging. Okay, again you can add multiple breakpoints. Simulation, add breakpoints. Go next. So in the variables, you can add variables to the watch list and then track them during simulation. Why you would do this? Because, and in general, you know, like why to track the variables? Because you want to see the values during simulation, and you can update those values. So here, for example, let's go back, run simulation. Let me remove that breakpoint. Remove. Now here, continue. I will add that to watch list, and I will add this one to watch list. Now I can track just watch list. I don't need to go through all the deep tree of the system properties and so on, like maybe thousands of them. I just see the watch list. Plus I can just manipulate those properties here. So you see, it's so easy, right? I can just play them with them here. Parametric constraints get automatically updated when you change inputs, and behavior gets updated based on the triggers. You see, it's updated, and then we see the results. So watch list is very important thing. I can right click, add to watch list, and then track that watch list during execution with all the characteristics of the watch list. Now, last but not least, is console pane. Here we can control the level of details, and we see what was the last executed element before simulation stopped. So if something is broken in the simulation, we'll see what happened before we quit. And also we can navigate to active elements. So when we run simulation, you see here we have this output, and we can switch here. And we can switch here. You see, nothing is output. Oh, this constraint was failed. That's why we saw, you see, failed. And we can navigate, you see, to the active element. At that time, requirement. Based on that requirement, it's constraint extracted from requirement text, which failed. That's why it printed, because we just want to see warnings or errors. But if we will switch to info, much more information will be printed, you see. All the calculations, whatever is done. In case of activities executed, here we would see activities, which one is executed. You see, do A, B, C, D, then inside of that activity, wait 5 seconds. So if suddenly something will quit, it will force that activity to quit, we would see what was the last activity, and you can again navigate to that in containment tree. Again, here we see the levels. Debugging will give the most details, error will be the least details. And don't forget to clean it in order to have clean console window. And last but not least, last simulations will be very hard to debug because there is a lot of things going on. So just copy the project with the new name and delete half of the project. So if you suspect something, you know, if something is not working, just delete everything, whatever you don't think that relates to that, you know, and see is that still reproducible, that still error is reproducible. And then if it is, then delete again, you know, and half, and in minutes, and even a few minutes, will find the problem, isolate the problem. How that works? So pretty much you run the simulation, something is not working, you know, like it does not recalculate, you know. So now I have at least two things here working. So selecting containment tree, you see like there is state machine and there is parametric diagram. So if I don't want that state machine will interact with my issue, I just delete that state machine. I don't have those activities also, you know, as a must. I delete them also, you know, and then I stop and run again, you know. And I look, okay, still the logic is here, right? Still I can actually change input and see result. Still the bug is here, or the bug is not here. If not here, then something what I deleted needs to be restored, which is like easy with Ctrl Z, or just opening the project again. If the bug still exists, that means it's here and isolated in parametric diagram. If the problem is still Persistent project is still too big. I delete again and again until I will get just one element with the problem. So one rule which will help you debug big projects is actually delete in half, check, and then again in half, check, and again in half. For the references, check the documentation. There is much more information. Even we consolidated the major advices, but you can check the debugging section. And let us know if you have more questions or insights. As always, we are open for suggestions and good insights. Thank you.